We are on section 4.3. We're going to solve some quadratics by factoring. First, we need to figure out how to factor. Just a reminder, if there is a single term, if it's just one term, we would call that a monomial. We have lots of different kinds of polynomials. If there's just one term, it's a monomial. If there are two terms, it's a binomial. If there are three terms, it's a trinomial. Now, if you look at the next three expressions, x squared plus 13x plus 40, the next one, these are all trinomials because they have 1, 2, 3 terms. Now, if I want to factor these, what we need to do, because there is just a 1x squared, okay, there's no number in front of the x squared, so if this is a 1, these are a little bit simpler than when we have a number in front of x squared that's different than 1. To start out with, x squared, if I want to factor that, it would be x and x. So I'm going to put that in the first two spots. Now what we need to do is we need to think of the factors of 40. 1 and 40, 2 and 20, 4 and 10, 8 and 5. Which of those factors are going to add or subtract to give us 13? So if you think about it, if I think about, we've got 1 and 40, 2 and 20, 4 and 10, 5 and 8. 5 and 8 would add up to 13. So I'm going to go ahead and use those numbers, 5 and 8 in the last two spots, and since it's a positive 13, these are both going to be plus. And then if you want to check your signs, a positive times a positive gives us a positive 40. Basically, you're doing the opposite of FOIL. If I were to FOIL this back out, I should end up with what we started with, this trinomial. Okay, and this is going to, because I'd have plus 8x plus 5x would give us 13x. Positive 5 times positive 8 gives us 40. Okay? Moving over to the next one, again, if I break up m squared, that's going to be m and m. Then we think of the factors of 51. 1 and 51, 3 and 17. I think that's it for that one. Are there any factors here that can give us a negative 16 in the middle? Could I subtract either of these to get a negative 16? I can't. So in this situation, you would say not factorable. Okay, not factorable. Always check and make sure. See if there are factors of 51 that would give us a 16. Moving over to the last one, again, we break up the x squared into x and x. And then you think about your factors of 10 that are going to give you 11. We've got 1 and 10, 2 and 5. That's about it. 1 and 10 would give us negative 11 if they were both negative. So I'm going to go negative 1, negative 10. Okay, so those both add up to be negative 11, and if I multiply them, negative 1 times negative 10, that would give me positive 10 at the end. So that one is factorable, and these are the factors. Now, you should get to a point where writing these out isn't necessary. Just think about them and decide which factors would add up to the middle number. Now, we also have some special products. You can still do these the same way, but this is a nice thing to look for. If you look at the 9, do I know the square root of 9? Square root of 9 is 3, because 3 times 3 is 9. So I can break this one up. We've got x and x. If you see that that's a square root, usually, not every time, but usually, those are the two numbers you're going to use. So I'm going to do 3 and 3, and sure enough, those are going to add up to negative 6 if I make them both negative. Always make sure you double check your signs though. Negative times a negative does give us a positive 9 here at the end. So that's what that factors into. You can also write this as x minus 3 squared. Next one. This is only factorable if you can take the square root of 9. And again, we can take the square root of 9. It's going to be 3 and 3. First, I'm going to break the t's up. We've got 3 and 3. Now, if you think about it, there's no t in the middle. So think of 0. If I make this positive 3 minus 3, that would give me no t in the middle. So that works. And then positive times a negative gives us this negative 9. Okay, so for this binomial, two terms, this would be the factored answer. Now for the last one, again, does 121 have a square root? It does. The square root of 121 is 11. I'm going to break these c's up. Now 11 is actually going to work because if I do 11 and 11, those do add up to be positive 22 in the middle if I make these both positive. And then check your signs. Positive times a positive gives us positive 121. And again, I can write this out as c plus 11 squared. Okay, so always look for square roots in the first and last terms. There's a neat quadratic. Now we're going to solve the equation. The first thing you need to make sure of is that one side of the equation equals 0. This first problem that we're going to do does have equals 0 on the right side. So that means we're ready to go ahead and factor it. So let's put this in factored form, which is what we just finished doing. Okay, we're going to break the x squared up into x and x. And then we think, what factors of 32 would give us negative 12? 8 times 4 is negative 12. By the way, it doesn't matter which order these are in. You could have 4 here and 8 here. That's fine, as long as your signs are right. Okay? Now, if I need a negative 12, these both have to be negative. Okay? So it adds up to negative 12 in the middle. Negative times a negative gives us the positive 32. Now, how do we solve this? You have to set both of these equal to 0. X minus 8 equals 0. Or x minus 4 equals 0. Because if you think about it, you don't need to write this down, but if you pay attention here, we've got a times b equals 0. If a times b equals 0, one of these has to be 0. Otherwise, this isn't possible. Okay? So that's basically what we're doing. We're letting this be 0, or this has to be 0. So we have two possible answers. Now if I add 8 to both sides on this one, x would be 8. Or add 4 to both sides on this one, and x would be 4. So we've got two answers. X is 8 or x is 4. Now if you notice, and this is a kind of a cool thing about when you have a 1 in front of this x squared, whenever you have your factored form, your answer is always going to be the opposite of what's in parentheses. So this is going to be positive 8, this is going to be positive 4. Let's do another one. This time we need to make sure that 0 is on one side of the equation. So I need to subtract this 2x in order to get 0 on one side. So this is going to be x squared minus 2x plus 35 equals 0. Now that one side equals 0, I'm ready to factor. Break up the x's, x and x. Factors of 35, that would give us negative 2. 7 and 5 will give us negative 2 if I make the 7 negative and the 5 positive. But now here we have an issue. Always check your signs. Negative 7 times positive 5 would give us a negative 35, and that's not the right sign. So think about it. Are there any other factors of 35 that would give us negative 2? I can't think of any. So in this situation, you would write not factorable. Okay? I'm not going to put not solvable because this is still solvable. We just haven't learned how to solve it yet. Let's try one more. Now again, we have 0 on a side, so we're ready to factor. Now, you may not know this right off the top of your head, but if I think of 196, I know that the square root of 196 is 14. And that comes in pretty handy on this one because I know that 14 plus 14 is 28. So I'm pretty sure that 14 is my factors, okay? So those add up to plus 28. Positive times a positive gives us the positive 196. So I'm ready to solve. Now in this situation, there's really no point in rewriting those twice because it's going to be the same answer either way. So if x plus 14 equals 0 and I subtract 14 from both sides, x is going to be negative 14. And that's my one simple answer. And again, remember when you have a 1 here in front of the x squared, it's going to be the opposite of whatever is in parentheses down here. So you may actually get into the habit of not having to do this part. You could just go straight to saying x equals negative 14. That's a pretty cool thing about those problems. Finding the zeros of a function by rewriting the function in intercept form. Now, if you think about it, finding the zeros is really finding the x-intercepts. It's finding where y would be 0. And if you think about x-intercepts, because they're on the x-axis, y is always 0. So when we're solving these problems, it's really no different than what we just finished doing. Okay? So we're just going to do a quick factor. We've got x and x. Factors of 18, that'll give us negative 3. That's going to be negative 6 and positive 3. Negative 6 plus 3 gives us the negative 3 in the middle. Negative 6 times positive 3 gives us the negative 18 at the end. So the zeros here, just like if we were solving these, if x minus 6 equals 0, then x would be 6. If x plus 3 equals 0, then x would be negative 3. So my zeros are positive 6 and negative 3. Those would be the zeros. Those would be the x-intercepts of that graph. And notice this is intercept form. Now let's rewrite the next one. Again, we'll quickly factor. I know that the square root of 64 is 8, which comes in pretty handy because 8 plus 8 is 16. And that's what I need in the middle. So we've got 16 in the middle, positive times a positive gives us positive 64. This time I only have one 0. If I were to set this equal to 0 and subtract 8, I know that my 0 would be negative 8. And again, because both of these sets of parentheses are the same, it's going to be the same answer. There's no need to write those twice. And that concludes section 4.3.